Welcome to the Actuarial Technology Summit 2025. This session is the value of programming to the actuarial profession. I would like to welcome the attendees as well as our live audience at Purdue University. Special thank you to the organizers for making this wonderful event possible. So my name is Igor Nikitin. I'm an actuary and a software engineer. I'm also a co-founder and CEO of Nice Technologies, and we are an AI-assisted actuarial modeling platform. So the actuary who is only an actuary is not an actuary. Frank Reddington, who is considered to be one of the greatest actuaries of all time, said this in 1968. This was before the AI, the cloud, the internet, and even computers. In today's world, this quote is just as true as it was in 1968. In this session, we will explore an option of being an actuary and a programmer. Why programmer as opposed to other disciplines? Why personal and professional benefit? What personal and professional benefits does it provide? And why is it a good choice in today's cultural, technological, and workforce contexts? Now, since 1968, we as actuaries got a lot more data. We got more complexity from modern insurance product design and regulation. We got more tools with a wide range of technologies and software. And ultimately, we got more things to learn. A decade ago, we all saw a lot of presentations on blockchain. But today, it is a niche technology that is useful only in specific use cases. Clearly, investing heavily in learning blockchain was not the right call from today's point of view. Today, as the world is all about AI, and tomorrow there will be more exciting technologies that would take center stage. The problem is that all of these skills and technologies require significant amount of time to learn. How do we choose the skills that would help us today and remain relevant for the rest of our career? What skills provide the best return on invested time? So programming is very efficient skill to learn because it is transferable, it applies to diverse set of problems, and it becomes increasingly relevant in the foreseeable future. It builds and evolves with one's career progression. At the entry level, it enables us to use excellent tools developed by the programming community, such as Git and DevOps for version and quality control. It lets us automate various day-to-day tasks, and it enables us to have a better understanding of the latest technologies, similar to how mathematics knowledge helps us understand new regulatory frameworks. Mid-career, the coding knowledge empowers us to work with large data sets and model complex logic faster and easier. At this stage, the focus tends to shift from programming ourselves to designing processes and using right technologies for the right problems. At the late stage of the career, programming knowledge allows to estimate time, cost, and value of various proposals. It enables us to separate hype from practical value. It empowers us to lead cross-functional teams efficiently. And ultimately, it allows us to identify opportunities and see where the world is going and how to position ourselves and our businesses in that world. The next tech breakthrough will integrate with Python first. And actuaries who understand Python will be well positioned to be the early adopters and leaders in those fields. The programming skill itself has underwent a very significant evolution, and there are two clear trends that kind of emerged out of that. So back in the day, programming used to be zeros and ones in binary. Then we got our very first programming language with assembly. As you can see, it required a very substantial syntax knowledge to be able to, and not only syntax, but also hardware knowledge to be able to efficiently use it. Then we got C++, which made things a little bit more user-friendly. Then we got Python, which is a higher level language, and you can do a lot more with a lot less code in Python. Then we got IntelliSense, which would complete our code based on what we have written, and that was very, very convenient for a while. We got a number of libraries that enable us to do sophisticated things like machine learning by simply downloading a free library and just in a couple dozen lines of code, you can do pretty sophisticated things. Moreover, nowadays there is a library for anything, connectivity, visualization, even AI, and it became very easy and accessible to work with these. And the latest innovation is AI Copilot. So now instead of knowing syntax at all, you can just write what you want the AI Copilot to do. So, for example, you can say, write me code that prints hello world. And it will actually do that, and it'll do it correctly. So the trend is for the reduction in necessary syntax knowledge, because now you can prompt with natural language, and syntax-wise, it will do a great job with converting that into code. But on the other hand, the engineering became increasingly complex. So what is the difference between programming and software engineering? Software engineering in the actuarial space is fundamentally about translating complex financial regulations and risk theory into automated, auditable, and scalable code. So programmers struggle with what to build, actuaries struggle with how to build it in a scalable and maintainable way. And actuarial software engineers are often possessing both actuarial and programming backgrounds to be able to connect the what to build with how to build it. Now, truth be told, it is usually comes at the expense of not being the best at either actuarial or the software engineering. And the key takeaways there is that cross-disciplinary collaboration is key to success. You have to let the programmers do the programming, and actuaries define what needs to be done, and each of them needs to give space to the other profession to do their job efficiently. Our peer professions, quants and data scientists, have embraced coding and served as an excellent sprint, and it served as an excellent springboard for them to get ahead in the use of machine learning and AI. They will likewise benefit from the next emerging technology, such as quantum compute. So I would argue that actuaries as a profession would likewise benefit from greater knowledge of programming. And programming will continue to provide value with future technological advances. As actuaries, we deal with a variety of tasks and settings. So anything from a quick R&D to check feasibility of something, to taking part in creating reliable production systems responsible for billions of dollars in premiums and reserves. These different tasks require different tools and different practices. Excel is often the best tool for R&D due to its flexibility and ease of use. It is great for delivering quick and cost-effective prototypes. On the other extreme, something like Python is much better suited for production systems requiring reliability, performance, and controls. Code fluency becomes increasingly valuable business skill because it helps identify the best tool and practice for the job and to strike the right balance of cost and benefit. Programming enables the use of many amazing tools. And let's talk about several of them. So for version control, there is Git. So Git is a software that allows version control of the code. So any kind of text-based files like actuarial formulas, for example. And it allows for very efficient version control. It allows for merging of the changes that were done by multiple developers. It basically allows for very efficient collaboration in a context of building models, not with a single person, like actuaries often do, but with a team of developers, each focusing on their specific task and then very quickly bringing it all together into one coherent and reliable system. The next tool I would want to talk about is Code Editor. So Visual Studio is just one of them. Obviously, there is PyCharm, there is VS Code, and a variety of other code editors. So the big advantage there is that code editors like Visual Studio have been developed by companies like Microsoft over the last 30 years or so. And the amount of thought, effort, and resources that was poured into a code editor like Visual Studio would probably exceed the budgets of some of the actuarial softwares altogether. So the the quality of the tools that you get from programming community is usually much higher than the quality of the tools that were bespokely built for particular actuarial applications, because there's a lot more users, there's a lot more money involved in serving those users, and there's a lot more experience in fine-tuning those tools to the tasks and the technological updates of the time. I would also want to talk about DevOps. So this concept is not very common in actuarial world, but very common in IT world. The idea is that you can continuously deploy the changes through automated testing and through well-defined pipelines of how the code changes will be managed and implemented. So everything from planning, who does what by when, to how the code is merged, how it's tested, what standards it has to conform to, etc. So tools like Azure DevOps make that process far easier than kind of manual logs of model changes and other practices that we often see as actuaries. For testing, there is PyTest, unit test, and a whole lot of other testing frameworks that enable very detailed testing of the software. And what it allows you to do is to have a regression test with thousands of tests as opposed to dozens of tests that are more common in the actual world. So the difference there is that by having a framework that is very efficient for testing, it actually allows the business to define and run those tests in a cost-effective way. And because it is efficient and cost-effective, you can actually have a lot more tests and much higher quality of the testing of the software. And last but not least is integration with emerging technology. So, for example, a lot of programming tools have got AI Copilot assistance over the last few years, but not a lot of actual modeling software did. And the reason for that is because user base of programming tools are much larger than the user base of actual models. And so once again, there's a lot more resources being poured in making technological integrations quicker and more accessible. So programming knowledge also enables choices and provides different ways of thinking about different problems. So a couple of examples here. If I want to save some data, right? As actuary, I would probably think of something like Excel, CSV. But as a programmer, I would also think about SQL Server. I would think about JSON. I would think about NoSQL. And I would have a basic understanding of what are the pros and cons of these tools. Now, once I do know that SQL, for example, might be a better fit for my use case, at that point, it's very important to recognize that the most knowledgeable actuary who knows about SQL would know basically nothing comparing to a professional software engineer who knows SQL. So at this point, you should go to a friend who does programming more professionally and say, okay, here's what I think I need. Can you help me with engineering of that? And is that the right fit for my problem? So similar with programming paradigms. So programming paradigms are different ways of organizing code or models or the formulas in those models. And they all have their pros and cons, and they all fit different jobs, right? So once again, familiarity helps identify some of the some of the ways in which some problems can be solved differently and perhaps more efficiently. And last example is computational tools, right? So as actuaries, we all use Excel for kind of light compute prototyping, and it is an amazing tool for that. But for some more computationally intense applications, knowing Python, knowing SQL, and knowing actuarial software is adds a lot of options and adds a lot of possibilities to how to tackle a problem. So ultimately, programming helps you pick the right tool for the job, and it expands your toolbox with possibilities that are beyond just the Excel and actual software. So, with all the media hype about the AI, some of you may ask, can I just vibe code it all? Can I simply ask ChatGPT to help me write any code I want? Will it become redundant to know programming in the future altogether? And the answer here is it really, really depends on your task. You may hear some speakers and prominent speakers say AI is absolutely amazing and generative AI is absolutely a replacement for the programmers. And you may hear some other prominent speakers say that, generative AI is like letting a bunch of interns run your company, and don't let them loose because nothing good will come out of that. Now, ironically, both of those speakers are actually right. And it really depends on what the use case that each of them have in mind when they talk about that. So, generative AI is very dependent on the underlying data and the amount of training data that is available. So, if you're talking about building websites, let's say, and something fairly standard like stores or like an Instagram type of website, right? Then generative AI will indeed do amazing. And in fact, even agentic AI will likely do really, really well. Why? Because there's plenty of examples in the training data of these models on how to do that and what it should look like. On the other hand, if you try to use generative AI for something like building an actual modeling platform, you will discover that it is probably worse than an intern because it just utterly doesn't know how to do it. And the reason for that is once again the availability of the training data, because how many actual modeling platforms, how much code for the actual modeling platforms exist on the internet? The answer is not a whole lot, if any. And because of that, the generative AI really, really struggles with that use case. So for any AI application, kind of consider how much training data is out there, and that would likely be a very good measure of whether it'll do really well in your task or very poorly. So what are the tasks that today's AI is really, really good at? So it is really good at tasks with a lot of training data. So, for example, general Python assistance, it is absolutely amazing at that. It is quite good at common tasks. So if you're automating passing data between some workbooks or saving it as CSVs and whatnot, it is a very common task. Because of that, there's a lot of examples on the internet, and because of that, generative AI will likely do perfect on that. Learning basics. So it is AI can be used as a coach for learning, and it usually does really, really well on basics. But as you go into more advanced topics, it tends to become less and less helpful with that. And it it is a result of kind of having less and less publicly available information in the training data set. AI is really good at summarization. Now, with summarization, one thing I would mention is when you summarize documents with AI, make sure you're aware of the privacy of the AIs that you're using. Because what I see more and more on ChatGPT and other AI platforms is data and talking points from proprietary papers. And the way that happens is somebody paid for the paper and then put it in a free version of ChatGPT for summarization. And now ChatGPT actually has all the data. And now somebody who did not pay for the paper can prompt the information, the proprietary information out of that paper. It'll be interesting what will ultimately happen to this through legal action. I would imagine it'll happen at some point. But the takeaways there, if you want to summarize something with AI, make sure that you know what the privacy settings of that particular AI are, and make sure that if you're feeding some proprietary information into it, it does not end up on the internet, and you are hopefully not the person who is the first to be sued for it. AI is quite good at document search, and it is indeed one of the really good applications for it. It's really good as a second opinion. And in fact, I'm doing a presentation later today on building out an AI for evaluating the data mapping and providing a quick second opinion on the data mapping exercise for pension risk transfer. Um, Now, in a more creative use cases, AI is really, really good at making images because my presentations have never looked better than they are today because I can actually generate the images for them. But just make sure that you generate images only when the number of fingers is not critical, because that is a common problem there. It is also worth noting that AI is different. AIs are different, have different proficiency at different tasks. So you may notice that, for example, Gemini is better at any questions related to IFRS and Solvency II for whatever odd reasons. And it also tends to be better at kind of realistic imagery comparing to ChatGPT. But ChatGPT also has certain areas where it holds the edge. So sometimes if you get bad answers, it's worthwhile to try to switch to a different model and see if you get better answers there. Um, some of the creative uses of AI is asking AI which of my emails did I not get a reply to. And the inverse of that is which emails did I forget to reply to? So there's a lot of very good use cases for it. Now, on the flip side, there are some problems with AI as well. So one, any problem with lack of training data, like actuarial software, for example, AI is of very limited use there. AI cannot be held accountable. So something that it produces, if it can't be explained and you cannot explain the sources of information, then well, it's a quick answer, but it's not a useful answer because you need to be able to sign off on things that you provide as an actuary. Complexity. So the more complex the task is, the worse usually the AI does. And that's where the idea of agentic AI came about, is kind of splitting the tasks into smaller portions and having individual AI agents work on that task in tandem. The problem is that if they work on something they're familiar with, they'll do decently well. But if it is something like actuarial regulations, it would look like a bunch of interns cooperated on trying to understand what this means. So usually not very useful. One thing that to pay attention to as well is anything that has multiple versions. For example, RBC regulations, which get periodically updated. And what I've noticed is that sometimes you get an answer and you would say, oh, wait, but I know that that's not true because that was changed in later revisions of that regulation. And then if you kind of dig into what did AI do, it is indeed pulling the outdated version of the information. So anything with multiple versions, just pay attention to how that came about. And last is cost. And I'm actually going to be doing a presentation later today as well on the cost of the AI. It is quite often easy to build a prototype for some process and say, okay, this is great, it's working, it does what I think it does. It produces useful output. But once you feed the production volume of data into it, you'll discover that you get a giant bill. And that is something that is certainly need to be considered on the prototyping of processes, as opposed to kind of discovering it later on after everything is already built and tested and a bunch of time is used to build it. Um, so AI is nowhere near to replacing senior developers, and I would like to pause on that a little bit as well. So Um, the reason why senior developers are still very much needed is because building architecture for large systems like actuarial software, it requires a lot of the things, it ticks a lot of the boxes which make AI not very good. It is a complex task. It has little training data. It requires a lot of accountability. And because of that, the architecture and design of such systems, it is not something that I see AI doing anytime soon, mostly because of the lack of the training data. It's hard to teach it to do it well if you don't have anything to teach it on. Um, Okay, and with that, I think we are on to questions. So this is a little shorter than I expected, but yeah. So please submit your questions in the chat, and I will be happy to reply to those. And same goes for our live audience.
Any questions?
Okay, I got the first question. What are your thoughts on Julia programming language as a potential skill for actuaries? Uh, so Julia is a language that is focused on computational performance. It is one of the Well, it's not that new, but it is more specialized, I would say, for the computationally heavy tasks. Now, that being said, I would say that it's a good second or third language to know. It is probably not the best first language, and reason for that is because popularity of a language matters, right? So if you know Python, Python is quite ubiquitous, and there's a lot of libraries and tools that would be released for Python first. So, for example, when AI integration libraries are released, I'm pretty sure that Python will be released way before Julia is. So I would say that it's a good addition to something more common and more mainstream like Python. I also see more and more questions about Julia, so I do think that um, it is quite it is becoming more noticeable in the actual work. Do you think that MCP servers can help address the gap in the AI use case for actuaries? Um, what does MCP mean? What does MCP stand for? Model context product. Okay. Um, LM model to call individual tools written deterministically. Okay, I see. Um, it would help for certain use cases. That is that is definitely one of the research directions of controlling the quality of the AI output. And for certain use cases, that would certainly be a good way of doing it. But the challenge is that if you have a lot of deterministic code that AI is then calling to execute tasks, then then AI is kind of relegated to just the orchestration, and at that point, it's really not that different from the orchestration tools that already exist. So it's a you. So it will help to solve certain types of problems where you need a mix of AI and something deterministic. But it kind of erodes a little bit the promise of AI as, just tell me what you want, and I'm going to go and do all of that, hopefully in an explainable fashion. For a lot of actuarial use cases, I think AI is for like financial analysis and that kind of thing. AI is still limited mostly because of explainability. And for even like large analysis of large volumes of data, I would often argue that hiring a data scientist is actually a better path because you will get much more understanding of the data and the problem comparing to just using AI. Any other questions? Thank you for the question, Ansar. Anybody else? Okay, so if there is no more questions, then we can end a little bit early. Thank you, everybody, for attending. Thank you, the live audience, and have a good day.